Yeah, good evening, everyone. Okay, we'll wait for 2 more minutes, so others will join. So session start by 4:05. Good evening, everyone. Okay, so today our agenda is to discuss practice programming assignment questions from week 3 and week 4. So if anybody have doubts in practice programming assignment, you can ask. I will discuss that. Otherwise, I will discuss one by one. First, I will discuss from week 3 and after that week 4. Or you want to discuss particular programming assignment, then I will discuss that. Am I audible?
Sir,
Yes,
week
sir.
3 practice
Okay.
programming assignment 2.
Yeah. 2, second one. No?
Second one.
This one, no?
Yes, sir.
Okay. Yeah. See here. So here we are going to compare two objects, no, in this program.
Yes, sir. I just what I did, sir. I'll just tell you. I just try to first construct the constructor by,
Okay. Okay.
and then just I get confused to get override the toString and equals method, because with means overriding, sir, as we know, if that one method is exist in one class, when I try to write the same method in another class, I will overriding that same thing. But here,
Yes.
where we are override with whom, sir? That this part is not clear.
Okay. Actually, this toString method and equals method. Okay. These two are already defined in the object class. These two are already defined in the object class. So if you not extend any class, okay, in your class, then by default, which is the base class for every Java program?
Object class.
Object, no? Then you have in your point class toString and equals. These two methods are already inherited from object class, no? So some default implementation is there for equals method and toString method. So here we are asking to override them and change the implementation according to your requirement.
That means we have to just simply write public toString method in.
No, toString method here, a toString method return string
Return
value, public
string
string is
value.
toString. Yeah. And equals method, what it returns? It returns Boolean value.
Boolean value.
Yeah. So we should override these two. Okay. And you should write, okay, the code according to your requirement. Okay. According to your requirement. See here, actually, here you are going to compare P1 and P2. Here you created two objects. What are the two objects? Point P1, P2. And you are going to compare P1 dot equals of P2. So actually, if you compare directly P1 dot P2, so it will return false by default, because these two are two different objects. Okay, two different objects. Even though these two are having same values, okay, these two are two different. Okay, because these two are pointing to two different memory locations. But here I want to override this equals method. Okay, this equals method, and I'm going to compare, okay, these values x1 and x2 and y1 and y2 in the p1 and p2. If these values are equal, then I'm going to display like this: p1 is equal to p2. If x1 or x2 or y1 or y2, okay, these two are, any one of these are not equal, then I'm going to display like p1 is not equal to p2, like that. That is the agenda here. Is it clear? Yeah.
Okay.
Yeah. Here, so in order to display like this, actually here you are displaying like p1 is equal to p2. Okay. So actually, whenever you display like this, p1 is equal to p2, directly you are displaying what? P1, P2, object references. So hash code will be displayed by default, because toString method by default, what it will return the, okay, hash code value of the object. Okay, but here we should display like this. Okay, what this 10 and 20, 10 and 20, these two are what? Instance variables of the what? Point one, yeah, P1 and P2. Okay, so we should override it and we should return those values x and y instead of hash code. Is it clear?
Yes,
so I will
sir.
type I will type the program.
Anand sir, can I
Okay,
show
sir.
something?
Yeah.
Can you let me share the screen?
Okay, shall I stop share?
Yeah, please. Just I want to show something so that I think it becomes easier for understanding. Can you see my screen?
Yes.
Are you getting some delay like when I'm talking? Or
No.
Okay. So see, we supposed to implement, supposed to override, not implement these two methods, toString and the equals, right? Now, can you tell me what is the use of toString method? Why I need this?
Sir, means it convert the input value to the string,
Any value to a string, right?
any value to the string.
Any value to a string. Now, the question is, the things happen. Suppose I write a system.out.println, right? And I have a int I equal to 10, and I'm passing a I into it. So what exactly happened? Can you tell me in this statement?
I get printed 10 with a value 10.
Okay, I get printed. That's the thing is. Now, suppose I write a point P, new point, say it's a 10 and 20. Suppose. Now, what will happen if I pass P?
Acha. It will print the uh, location where this 10 and 20 points stored under the object of P.
Location means the address you want to say?
Memory location, yes.
Actually, in Java, you never can get the actual memory location. It gives you a hash code, right? It returns
What's a
a
hash code?
hash code, a hash value,
Okay.
message digest kind of thing, right? A message digest of kind of thing. A message digest kind of thing. Now,
Okay.
can I print the value of P like this? Like instead of hash code, suppose I want it has to be printed like this. Like I want the output has to come like 10 and 20, right? Suppose I want to print the I know it will become a 10, but I want the point, if it is printed with the println, and I want the output becomes like this. Now, this can be done because whenever you call for this, internally what happens? It basically call for a toString. And from this, where this toString method is coming, it is basically coming from the object. Even you don't write it, inside the object class, this toString method is already implemented. So it calls this, and then the I gets printed. So similarly, whenever you are printing P also, internally it calls this toString method. Now inside the object, the toString method for a reference type is a reference type, right? P is a reference to an object, right?
Mhm.
P is a reference type. Do you understand the term reference type?
Reference type. Type, sir.
Yeah.
Yes, sir.
I stores a value, right? I stores a value. So
Hmm.
whenever I say the primitive type like int, float, double, I call them as a value type. But
Hmm.
whenever I'm having a object type, I
Hmm.
call them as a reference type. It refers to a object, right?
Correct.
So now whenever I call this toString against the reference type, since this toString is not specifically implemented for the class, it do what? By default, the code is written inside the object class, print the hash code of the location, right? So it will be printing with the hash code. But what I can do, whenever I'm defining the point, I can override the toString function and I can specify the way I want to print it, right? So toString do what? ToString basically returns a string. So what I do, using my values, I create a string and I return the string which has to be printed. So that's how, if I have implementation of toString and here I call p.toString, what will happen? This toString will return this formatted string within the parenthesis, the value of x plus value of y. So definitely the output will become like this. Are you getting up to
Yes.
this?
Yes.
Now this toString you don't have to call explicitly because this will be internally called by the system.
Hmm.
That's the beauty. So that's how, just with this much code, say I comment the rest of the part. Because this portion has to be used in many program in Java. because this is a practice. Like instead of calling print display, why not pass the object inside the println and get it printed, right? So this is very so see, it is getting printed like 10 and 20, right?
Yes, yes, yes.
Even format. So this is why you actually require this toString has to be thing, right? To be overridden. Suppose you want to declare a class called as a complex number. You want to print it as a real plus the imaginary portion suffixed with I. And you want a complex object is passed into the print function, means it will be printed like that. But normally if you don't override the toString, it will give the hash code of the particular object. So inside the complex class, if you override the toString and appropriately write a string like how it has to be printed, you get it as a desired output, right? So this is the first how you can, what is the use of toString. Okay. Now next portion, why you need to override equals. So why not we check it using equality? Because we are having this operator, no? Right? But my question is, you can compare two integers, right? You can compare to double value, you can compare to character, but is this implemented for any other class also? You cannot guarantee that, no, because you do not know how two employees will be compared, how two students will be compared, right? So for them, you need to implement how the equality has to be checked. Suppose for two employees, the employee IDs are equal, you say the employees are same. Suppose for the students, if you say the roll number and the class number is same, means the students are same, right? So there could be different logic for a class to check the equality, right? So that's why it gives you a scope that you can check, you can write your own code to verify the equality also. So here, if you look at here, what I'm doing inside this main, so this code is given to you. We say the point P1 equals to P2. See, if they're equals, it's supposed to return a true. If they're not equals, they're supposed to return a false. That's all, right? But where this equals is written, this equals is not written by me, it's written by the object class. So that knows how to compare the basic data types. But whenever I'm going to do it for a user defined data type like a class, I need to implement my own equals. So that's why I go for overriding the equals method. So what is my logic to override the equals method? Just look at this part, the upper two lines I'm going afterwards. So anybody can explain why I'm doing this casting?
Just to make sure that what object is passing, it is a class type as point. Type casting.
No, the thing is that every time you refer to OB and you want to call it, so you have to cast it. So getting this T, then makes it easier, right? Next time you just refer to T dot X and T dot.
See, you're having a parent class, suppose A, a parent class, suppose A, which is inherited by a child class B, right? Now suppose you are having object of A is OA, sorry, OA, and I'm not writing new and all. Okay, please understand it is already there. OB. Now, can I write OA equal to OB? Is it possible?
No.
No.
No, you cannot write.
Sure.
If the type of A and B is,
we cannot write OB equal to OA, but we can write OA equal to OB.
Yes, because they are related classes, no, inherited. So what we have learned, a parent type can always refer to a child type object, right? A parent type can always refer to its own object and its child object also, no? So OA is a parent type, right? And OB is a child type.
Okay, so that way OA equal to OB. So whoever calls equals can pass any object, but I can take this here as object.
I'm not getting. Can
I
you
mean,
repeat, please?
whoever calls equals can pass any class.
This is not equals. This is assignment.
No, what I'm saying in this code, the code above, somebody is calling equals. They could
No,
have
I'm going
passed.
for that. But are you clear about this line? This is more fundamental line. That has to be
Okay,
clear.
so OA equal OB is possible. Yeah, I'm clear about that. Yeah.
Okay. Just wait for a minute. So everyone is clear about this, no? Because this
sorry,
is the
what-
fundamental of the dynamic nature of the Java. This is the key of the dynamic nature.
Sorry,
If
one
you are
minute.
not,
See, B is inheriting A, right? So A is your parent class and B is child class.
yeah, that's always
How you
possible.
are putting OA, you are assigning to OB. But if OB has an extra parameter, how OA is going to assign it? It cannot take that value, right?
Yeah.
So is this statement correct? OA equals to OB? It's not correct statement.
Yeah, it's correct, right?
Yes, it's correct. Because
Oh,
A is subset of B.
A is a subset of a B. Yeah,
That is why it is. It
it
can.
is correct. No, it can possibly.
so which one is parent class, A or B?
A is the parent class. So what you will have inside OB, sorry, what will have inside the OA, definitely that will be in OB, right?
Right, but OB can have extra parameters, right?
Yeah, that I won't take.
Then how you can write OA equals to OB? If OB has extra parameter, then it cannot assign it, right? Parameter means I am telling method.
Yeah, that is I'm telling.
Okay,
See,
okay.
the rule is if you have a reference can refer to its own object and child object, because a parent is a generalization of the child. So we can say child is a parent. Like I'm telling, if I say employee and manager, I can say manager is an employee, right? It is
Right.
similar to that, right? B is a A. Is it not? See, if I write employee manager, I can say manager is a employee. So here, why not I can say B is a A. If B is a, is it not the same thing?
So, okay.
Got it.
We are assigning it. Okay.
But can I write? Yeah, this is possible.
No.
No. Yes.
See, in runtime, it may be possible, may not be possible, right? We cannot guarantee, but compile time, it is not possible. It will give you a compiler error. This casting has to be a explicit casting. This casting has to be a explicit casting in compile time, right? In compile time, it has to be a explicit casting, isn't it?
Yes, sir. But if in the program, if we see the method that A and B is having, but the calling method, it's common to.
I'll give you an example after doing this where it is possible. Okay.
Okay.
Just wait for a minute. Just remember, if you want to go from child to parent, it is the implicit casting. If you want to go from parent to child, it is the explicit casting. Is it clear up to this?
Yes.
Okay. So OB is of what type?
Object type.
And T is of what type?
Point.
So what kind of casting is required?
This is child to parent, so I need to
Where
cast
child
it.
to parent? OB is what type?
B is parent.
So parent to child, no?
Parent to child. Sorry. Yeah.
So parent to child means the second situation, this one, right? It has to be explicit. But this is always true, right? See, if I say T is a OB, A point is always an object. That's obviously true, right? But an object may or may not be a point, right? So that's why it is explicit. Try to understand this very clearly. If I write OB equal to T, this is obvious. A point is always an object. You don't require any casting. A point is always an object, right? But a object may be or may not be a point, right? The reverse may not be true. So that's why the explicit casting is required. Is it okay?
Yeah.
Yes, sir.
So now it's a simple thing. If the x of the objects are equal, y also equal, then I say true. Otherwise, I say false, right? Now, can you tell me why these two lines are required? First two lines.
Because I could be called by with some other object, which is not really a point.
Yeah, OB may not be a point object, no? How do you ensure OB will be always a point object? It could be a complex number object. Now, suppose this OB is a complex number object and you are trying to cast it to the point. What will happen? Suppose OB is not a point object, it's some other type of object.
No.
So casting will be failed, right?
Yeah, right.
Yes.
So
Will
it
the
will give
casting
a
fail, or will it be a invalid? I mean, it will be a runtime.
it will give a runtime exception, right?
Okay.
It will give a runtime. See, the casting is only possible whenever we are having the related classes like parent-child relationship, some kind of. Otherwise, the casting will fail, right? So that's why first I am checking is OB is point object or not, right? Is OB is a object of point? It's a yes, then only I will do this. If it is not true, then I know I can compare between 2 points. If one is point, another is something else, so the comparison is not possible. So I directly will return a false, right? What this instance of is?
Since this is basically a internal this thing to find whether this is a
Internal what? Exactly.
It is just
The
a Java.
object of the point class
I don't know what to call it, right? Operator, actually.
It is an operator, yes.
Right?
That's
It
what I
will just
want
say
to know.
whether this particular object is an instance of the
Instance of a thing, yeah. It returns a true or false. It's an operator, right? Yeah. So that is what this will do, right? This program will do. Okay, I'll just show you this type.
So
of,
one question, sir.
please.
Since we are doing the method overriding, right?
Yeah.
The line number 13, line number 9, I do not have any problem because it is the same because no parameter is there. But equal object here you are calling with some parameter. How it is overriding?
In the object class also you are having the same signature.
No,
to
it's
guarantee in the object class also you are having the same. See, our object.
that
will
I
be
am not able
compared
to
with
see now.
So that you need to remember. See.
No, sir.
I say try to understand.
In the portal, sir, in the portal, when we are writing this program, they have written their equal parenthesis and then
No,
tostring.
it won't be given to you. You have to know this.
Achha.
See, tostring will convert a operand to a string. It is a unary kind of function, right? So object dot tostring. But whenever a object dot equals, you need to understand it has to be compared with another object, right? So how do you pass another object? It is quite intuitive, no? Say, if I want to convert a operand to a string, I'll say operand dot string. It will be converted. But whenever I want to compare something, equality, so I need two objects, no? An object dot equals with what? That has to be passed, right?
Okay.
Okay. I'm quickly writing a code. Just check out. Can you answer this or not? Yeah, Puneet, please.
Yes, sir. A quick question.
Yeah.
In line 17, if I replace the type of object, if I just say point.
Yeah, I'm replacing it.
And if I know that this is only for supporting point.
Yeah.
This object, I don't need to check for instance and return false for all other objects, right?
right?
That should be okay, right?
It should be okay, right? But it is not overriding the equals which is there in the object
Yeah,
class.
only
So
for point. Yeah, it's only going to operate for this point.
as the question asks, you need to override. So you should do this. Yeah.
But this is overridden for the point, right? For point class, it has overridden equals.
No. Which equals you are overriding? You are overriding the equals which is written for the object class. Object inside the object class, the signature of the equals is writing here object, right? So whenever you want to override a class, override a method, you need the signature to be exactly same, right?
Okay. Is there an advantage of overriding for the entire object, for the object class?
It makes a generic, no? You can override it for any class, right? If you make it point, it is specifically implement for the point only, right? So inside the object class, you are having a generic kind of thing. So object means anything could be compared, right?
But then it will not give a compile error if I try to pass a wrong type of object. Like if I try to pass a string for an
Yeah,
integer.
in this case it will give, because here I am specific to a point, but inside the object it gives you a scope, you can make it generic. That is what I am going to say.
Yeah, but this will not give me a compile error. If I'm a coding and if somebody else is coding with my classes, they
Yeah.
can write the code with passing the wrong object, right? It may not be a point. So that will
Yeah,
not
that depends on how
error.
you are writing your code. Suppose you are having a employee and student, and somehow you want to compare a employee with a student, right?
Right.
And student is somehow related with not an employee student. I'm giving you a wrong example. So a student and a employee and a manager who are having an inheritance relationship. So in that case, the comparison is quite possible, right?
Yeah, but the program becomes lenient. It absorbs one syntax error. I'm going from that perspective.
No. If
This is dilating the case that somebody by mistake might present a wrong type of object to the
no, whenever I do inheritance, sometime I want it to be passed, because I mean to say manager is also an employee. So why not compare a manager ID with an employee ID?
Okay, all right, fair enough.
Getting my point?
Okay, so the reason we are using object is because we need to override the object class. That's why I cannot use
See, I'm
point.
not saying you have to always use an object class. Why I'm saying I'm writing here object, because question says you have to override the equals which is written on the object class. And how it is written on the object class equal function signature, it takes the argument of the object type, right?
Okay.
Now overriding say you need to keep the signature as it is, as the parent, right?
Right. Yeah.
Since on the object class it takes a parameter as an object, I'll also write the same signature. That's all.
Okay, got it. Thank you.
Okay, quickly I'm writing another code because today is a coding day. I suppose I can write any code until and unless it is very wrong or something. So void f. Okay, let me have a system.out.println, and what I say a colon f. So yeah, and class b. We have done inheritance, right? We have done
Yes.
inheritance, right? Yeah.
Yes,
Okay.
yes.
Okay. Few first week I haven't followed, so that's why I'm asking. Println. Okay. So I write b colon f. Up to this, is this okay? Plus I write it if class public static void main string args. Okay. First question is it possible or not? Sorry. First question is it possible or not?
Yeah, it is possible.
Okay. If I call AO.F, what should be my output?
A::F.
Hmm.
Sure.
Be BO.F.
It will be B colon colon F.
Just give me a minute. I'll share a blank sheet. Let me check if I have a blank sheet to draw something. Okay. Okay. So if you look at this line, AO is a reference, right? Where it is pointing to an object which
Which is
is
of type BO.
of B, object
Yeah.
of type B.
Yes.
So which was initially referred by
B.
BO. So now we can say BO and AO both are referring to the same object, right? So you
Yes.
may call AO.F or BO.F. Does it means any difference?
No, they'll be the same.
They will be the same because in both the cases it is going to be called from the B. Right? So anybody confused? Please clear up your doubt because we are going for the much tougher thing.
No, sir. This is Srinivasan here. I am not confused because I'm just trying to create an analogy with C, right? Two different structures I can, finally, but I will refer to the
Yeah,
same location
malloc
of the structure.
allocated something on the heap, you are putting a pointer.
Yes.
Just allocating another pointer to it. It's the same thing. The object is actually created on the heap. You're just taking a reference. The initial reference was a BO. So it was already referred by a BO. Now making BO equal to AO means AO and BO both are referring to the same object. You do AO or BO does not matter. Right? Sure, no, everybody clear, right?
Yeah. By the way, just to be clear, in this case, A equal to new A, that is not necessary, right? I can just declare A to be of type
Just
A.
I'll be reusing it for some other reason.
Okay.
It's not required. Okay. Now, can I write BO AO?
No.
So is it a compile time error? It's a
It is
compile time
runtime.
error. It is a compile time error. It say cannot convert A to B. Right? So this is not possible, but it is possible if I do a explicit casting. Now is it okay?
Yeah.
Okay. Now have you heard of that method dispatcher, that term? Somewhere in the week 1, week 2? Week 2, I suppose it's there.
What's the method?
Method lookup, method dispatcher, these terms. Method lookup definitely have come across, right?
So we've come across dynamic dispatch.
Yeah.
Dynamic dispatch, yeah.
In
Or
week
method
3.
dispatch, yeah.
Yeah.
Both all are the same thing. Actually, the dynamic lookup also the same thing. Now the rule tells us that a reference can refer to its own object or its child object. Please, if you don't know, please write it down because this is the main concept of the dynamic nature of Java. A reference can refer to its own object or its child object. It never can refer to its parent object. It never can refer to its parent object. It's a runtime error. It's a runtime error. So compile time cannot detect it because compile time do not know at the runtime where you will be pointing to, right? So When you execute your program, you know where your references are actually pointing to. It is pointing to a parent type or child type, right? So that's why in compile time, this won't give any error, because compile time it says the compiler checks if you are doing a child to parent kind of thing, sorry, parent to child kind of thing, it should be a explicit casting. That's all. So it's correct for the compiler. But runtime checks for the left hand side, whatever the reference you are using, does it refer to its own object or child object? If it is not, raise a error on the runtime. Now question is, we are basically successfully avoided the compile time error. If I do this, you won't get a compile time error, but will this code run?
It seems there will be something that is defined in A, right? Whatever is defined in A, it will work.
Now, does it fulfill the dynamic method dispatcher or the dynamic lookup rule? Does the reference refer to its own type or child type?
Oh no, okay, parent, right? It refers to the parent, so it will fail.
It is
Runtime.
always a wrong. It is always a runtime error. It goes against the dynamic method dispatcher. So that's how, if I try to run this, compile time, it won't give me an issue, but on the runtime, it gives you error.
This is silly. Can you just show the run part again?
See, how do you understand it's a compile? It is stopped me. It do not let me run. If I say proceed, it say the compile time error. Right. Now I do explicit casting. It is not stopping me, but whenever executing, it is giving me the error.
Okay, got it.
Okay. So everyone fine, right? Everyone fine, right? Yes or no?
Yes, yes.
Okay. So let me make it a bit complicated. Okay. Okay. You told I can write this. It is okay, right?
Yes, right.
Agreed. Yeah. Please tell me. Yeah. Okay. Now, it is compile time. Is it okay? In
Yes.
compile time, it's okay because I'm doing a explicit casting. Runtime, is it okay?
No, runtime is not okay still, no?
Yeah, not okay, not okay.
Are you sure? Please check carefully.
Oh, because the reference is okay. Runtime it will go through because you have set it equal to the B type. Okay.
See, please try to follow. This is very, very important. Okay. First, look at where BO was pointing to. B was pointing to what? A B object, right? Right. Then I made this AO pointing to the same, isn't it? So BO and AO both are pointing to the B object.
Yes.
Now where the B1 is pointing to?
Same as either BO or AO. Yeah. It's
Same.
another pointer to the
But
same.
object is of what type? Now
B
object
type.
is of type of B. So BO1 is referring to its own object, no?
So it will go through. Yeah.
Yeah, because it is fulfilling the dynamic dispatcher. So that's why I'm telling writing this is always not wrong if it is of the same type of the object.
So what is the difference between 19th line and the 25th line?
25th line, BO is pointing to which type of object? Object type is what?
So it's B.
Is it B?
A type, sir, but we are externally typecasting, right?
But does it change the object? Does it change the object? See, AO was pointing to what? A object of A. Object is created in a memory, that memory chunk, that is a A object. It is having a snapshot of the class A, right? Now,
Yes.
where this BO will point to? BO will point to what? The same thing. Now, what is the type of BO? The BO type is B and the object type is A. This casting is happening between two reference. The casting is not happening to the object. Try to understand. AO is a reference which I am casting to B.
Okay, sir.
But object is somewhere on the heap which I cannot change. So I am playing with my variables, but memory which is allocated actually on the heap, that I cannot change. Right? But in this case, if you look at, since this AO is referring to actually B object, this BO1 also will refer to the B object only. So it is referring to its own type, right? So that's why we can bypass the error in this case.
Also, can you please explain how do we decide where the variable, which type of object the variable is referring to?
First, the rule you got it, right? I can refer to my own object or my child object.
Yes, sir.
I cannot refer to my parent object, right?
Yes, sir. This I got.
So let us check out with this line, right? So, let us first start with this line. Go step by step. Now, first compile, look at what? Compile, look at if the casting is typecasting is possible or not. Means both the variable you are assigning to, they are compatible type or not, right? It do not know which is the value actually stored on the memory, because until and unless you run your program, how do I know where is the memory, where the values are stored, what is the address? We don't have this information, but only the information I have in the compile time, what is the data type of BO and what is the data type of AO. Agreed?
Yes, sir.
So compiler check that these types are compatible or not. How do I check the types are compatible or not? You can do a implicit casting between the same type or child to parent, right? Implicit casting between the same type or child to parent. But if you want to go parent to child, it has to be a explicit casting. Only this rule. Is it clear?
Yes, sir. That is clear.
Okay. So compiler first check this. So is it okay with the compiler? It is casting from child to parent. So it is an implicit casting.
Yes,
Compiler say yes.
Yes.
So compiler only understand this. Okay. Now just forget about the type and all, because compiler already checked up it. Now actually come to the runtime. In runtime, what is happening? The AO is actually pointing to what? AO is actually pointing to an object of A and BO is pointing to an object of B. BO is pointing to, BO is pointing to an object of B and AO is pointing to an object of A. This is the first thing is happening. Now in this line, what is happening? I say where BO is referring, AO also will refer on the same thing. What I am saying? Where BO was referring, I'll also refer to the same thing. AO also will refer to the same thing. So BO was referring to what? BO was referring to a B object. So AO also will refer to the same object. So both are referring to B. Both are referring to a object of B. Now question is, yeah.
So is it like where the RHS will refer to the same location, the LHS will also refer to?
Yeah, So I'm copying this, no? So if you assume this is just an address of this object, actually it's not an address in case of Java. This address, this, or rather say it's a location. That's much more correct conceptually. So the location of B is there inside BO. So that location will be copied into AO. Right?
Okay, so means AO is being assigned the location of BO.
Yeah.
Okay.
The same location AO also will have.
Okay, sir.
So both are pointing to a B object. Now runtime asks me the question, is it fulfilling my rule of dynamic method dispatcher? Right? This is the concern of the runtime now. So what the dynamic dispatcher say? You can refer to your own type or child type, but you cannot refer to your parent type. So thus this rule is fulfilled?
Yes, sir.
Yes. So done. There is no error. So compile time I am clean, runtime also clean. Now come to this. Now compiler check for this. Is it okay for compiler?
No.
No. Because compiler said parent to child, it should be explicit.
Right.
Parent to child, it should be explicit. Child to parent, it's a implicit, but parent to child, it's a explicit. Because every child is a parent type, but parent type may not be of a child type. Similarly, I can say manager is always an employee, but employee must not be a manager, right? So that's why this casting is required. I am forcefully saying, yes, this manager is an employee. Sorry, this employee is a manager. But to recognize a manager is an employee, you don't have to recognize it, right? Because by default, every manager is an employee. But if you want to say employee is a manager, you need to enforce it. So now it is compile time okay. But is it runtime okay?
No, sir.
Why?
So because we discussed that an object can never refer to its parent. It can only refer to
Not
itself.
object. See, try to be clear about it. Object is actually created in the memory and reference which stored the location. References which stored the location of the object. So these BO, AO, these are all are references. So you should say a reference should refer to its own object or its child object, but it cannot refer to a parent object. Remember, this is the object, but these are the reference. What you tried to say, it's correct, I understand, but be correct with your term. Whenever I write BO, I say BO refers to, because BO is a reference. BO refers to where AO also refers. So what AO refers? AO refers to an object A, but BO is a reference of which type? Child type, B type. So it is not fulfilling the requirement of dynamic method dispatcher. Am I clear? Am I clear? What happened?
Yes, sir.
Sure, no, you're not telling anything. I don't. If you have some doubt, you can still tell me.
Just one doubt. When you are doing this typecasting for OA to B, so you are telling we can convert the reference, but we cannot convert its class. That's why the
You can
BO
convert a reference, not the object. Not class is a data type, is a type, right? Class is a different thing. See, if you look at over here, if I say A, your object is created somewhere in the memory. This A just locate to it. Now, if I say B equal to A, that means I take a B which also points to the same thing. Sorry,
Right.
which also points to the same. So these A and B are what? These are references. But your object is this, right? This is what I'm trying to say. Clear or not? Please confirm.
No, when you are telling this OA and BO and OA, when it is referring to a that memory location. So if I will change something in OA, it will reflect into BA. Okay.
Yeah.
It
Yes,
cannot be
obviously.
equals to OA because we cannot. You can say reference from a parent to a child. That's okay.
Yeah.
But when we are doing this typecasting B, why it is not allowed? We are casting it, right?
No, you are again confusing between the casting and referring. Typecasting means one reference is typecasted to another type reference. That's a compiler job, right? It checks the particular reference are of compatible type or not. That's all. But reference referring to an object, that's a runtime situation, right? What I'm saying, I can refer to an object if it is my own object, means my type object or my child type object. So as I am a type reference, I'll expect my object will be a object or B object. But if I am a reference of B type, I can only refer to a B type object. I cannot refer to a type object. Simple that.
Okay.
Now what about this?
So here we say that AO is pointing to type B object because we have typecasted it over there, right?
Again, you are confusing between the typecasting and object. One minute. Let me have my enter. You need to see the thing separately. That is not happening. Can you see? Yeah, here. This is my notepad kind of thing.
Yes, sir.
Suppose you are having an employee which is inherited by a manager. Can I say this? A manager is a Can I do this? A manager can be treated as an employee.
Yes.
A manager is an employee, right?
Yes.
But if you say EMP, I want to treat a employee like a manager. Is it true?
Not possible. Not allowed.
Not always possible. It may be or may not.
Yeah, you have to pass this here. You need to have the right casting. Yeah.
So if I have, that's why this, you have AO. Is it not the same thing as this? Is these two are not the same thing?
So they are same. So but
They are
here,
same.
when you write AAO is equal to new A, we're creating an object of class
For the time
A.
being, forget about the object. I'm just checking about typecasting is possible or not. Means assignment is possible or not.
Yes, sir.
Because I'm on the compile time. See, object will be created on the runtime, right? Can you have an object on the compile time?
No, sir.
No, right? Say class is a kind of a blueprint. It's a type. So actually, whenever I realize, like I create the building, I'll say I'll got my object. So that creation of the object will happen on the runtime. So suppose I'm on a compilation phase, so I don't have to think about the object at all, right? So just think about the assignment is possible or not. So this assignment is quite possible. But is it possible?
No, it is not possible.
Because it may not happen, right?
Right.
So that's why the correct way to do it, I enforce in the sense I say compiler, don't worry, I know it will be B. Means this employee is manager as a programmer, I'm guaranteeing you. So that's why explicit casting I do. Means compiler may not be sure, but I am sure. I am telling the compiler, yeah, you can do this because I am guaranteeing you. So this is only the concern of the compiler. You don't have to understand anything else about the compilation of this. Is it okay?
Yes, sir.
Everybody clear, right? So I'll erase this. Okay.
Yes, sir.
Okay. So after these two steps, I am doing AO, BO. So compile time it is okay, but I want to check. Now I'm running my program. When I running my program, I want to check out execution also will be proper or not. So now in this line, what happens? AO, a reference will be created which is pointing to a object of A. I'll create a BO which refers to a object of B. Right? Now in this line, what is happening? I say AO refers to the same reference of BO. That means now AO will refer to this. This is what is happening on the runtime. Compiler do not understand this, right? Now the question is this assignment is correct or not? Now what is your reference type? What is your reference type?
E.
A, the parent type. What is your object type?
B.
B, it's a child type. So does it fulfill the rule of dynamic method dispatcher?
Yes, sir.
Yes. So done. Okay. Now let me change this. Now I say BO, AO. So first thing, compiler will stop me. I cannot do this. To bypass the compiler or through it, to process it through my compiler, I write it like this. But is it legal by the runtime or not? I want to check out. Right. So how do I check out? I have AO referring to a object of A, BO referring to a object of B, right? Now I'm saying BO must refer to AO, right? Now I have to check this assignment is correct or not. What is the type of BO? What is the type of BO?
B.
B. What is the object type?
A. So it's not compatible.
It is not compatible, right? Because dynamic dispatchers say the reference can refer to its own type and child type only. It cannot refer to parent. Okay, so I'll go for the third case. Please try to follow. A, B, B, right? OA equal to OB, then B, OB1 equal to B of A. Now first run the compiler and tell me is there any error in the code. Just run the compiler first. Don't think about your object runtime. First, only check will it compile or not.
So it will compile.
It will compile. Everybody agreed, right?
Yes, sir.
So now look at step by step what I am doing. Okay. So first line, what is happening? Our OA reference is getting created and it is pointing to an object of A. Then I'm creating a OB which is pointing to an object of B. I think no doubt. Then I create, I basically makes OA assigned to OB. That means this will go up. Is it legal? Is it legal?
Yes, sir.
Yes, sir.
Now I create another reference OB and I point it to OA. Where the OA is pointing to? Is this legal?
Yes.
It is legal now, right?
Yes, sir.
Because this is also type of B, object is of type of B. Done. Everyone okay?
Yes.
Sure,
So
no?
yeah. Internally, is it that when the object is stored, there is some information about which class it is and all that also, right?
You mean to say?
No, okay. I just trying to ask an internal representation, but that's okay. I'll please skip
In the
question.
memory heap.
Yeah, in the heap, I think there
Yeah,
is some
you can
reference
extract
to.
the information on the runtime. So there should be some kind of metadata about it.
Okay, and that is what is being used to check whether the runtime thing is okay.
We'll go for something called as a reflection, where you can find out on the runtime, you can find out some information about the object. So that we'll do on the week 5 itself, I think. Right?
Okay. Okay.
Okay.
So
One more
so
thing.
one thing. So when you write in the last line on RHS, when you write BOA, so it means that you are pointing the reference OA to an object type B.
We are
making the reference OA point to an object type B. Is it?
See, these casting having only a role during the compilation.
Yes,
right?
sir. Yes, sir.
It doesn't have any role to play whenever we are in this thing, no? See, suppose this line is not there. Suppose I don't write this line. So what is the scenario? OA points to an object of A. OB points to an object of B. Right? Then I say OB1 points to OA. Means it is basically point to a type object. So this casting doesn't change your object. It is only for casting your reference during the assignment. So in this case, it will be a wrong statement, right?
Yes, sir. Got it. Got it.
Okay, a simple question will go in much details in next this thing, because we need to go back to our programming. That is, we are planned for today. Suppose we have a F. We are having a B. This is concept, just I'll give you. It is having a G. So you need to remember, by default, B is also having F, right? Is it not?
Yes, correct.
Yes, sir.
Okay. So now, if I have OA equal to new B, right? Is it correct statement? Is it a correct statement?
Yes, sir.
Yes, sir. Yes.
Yeah. OA refers to an object of B, right? So OA is a parent type referring to a child type. It's correct. Now question is, if I call OA dot F, which function will be called?
So the B's F
Is
function
will be called, because OA is now pointing to B, right? So it will call the F which is from B. If I say OA dot G, Now,
Both will be called.
anybody?
Both will call, right?
No. Whenever I call a function, your capability will be as per this, but implementation will be as per the object. Again, I say sorry, I rounded it and wrong.
Can you repeat that, sir? Capability.
I'm telling you. Your capability will be as per this. This say the capability. But your implementation will be as per this.
Okay, so that way OA.f will call B.f. OA.g is not allowed.
This error. Because A doesn't have this capability only, right? Because you're in type A. Say, a manager can be an employee, that does not a problem, but he cannot manage the department, right?
Yeah. So, sir, in this case, where would the error come, in runtime or compile time?
Runtime. No. We'll get it compile time, right? Anand sir, we'll get it compile time only. So
Yes,
I
sir.
think it will come in the compile time. Yeah.
Yeah.
So this is the concept. Yeah. Okay. I think we can go for the next program. We are taking too much time. If you have any doubt, we can also discuss next day about this. I'll stop. Anand sir, please. I took too much time. Yeah. Sorry.
But
Okay,
this is very, I think this is quite useful for later things also. Thank you for that time.
Yeah, Anand.
Okay, so week 3, okay, no? So if you have any doubts in week 3, like in programming assignment or you can ask.
So
Otherwise,
actually, I
we'll go
found
for-
week 3 simpler than week 2 in terms of assignment. So I finished it.
Okay. So shall I move to week 4?
Yeah.
Yes.
Yes, please.
Okay, so here also I'm giving choice to you only. So which question I want to I should discuss, whether you have particular thing to discuss or whether I have to discuss one by one.
One by one, sir.
No? Am I audible?
Yeah, Anand sir, you're audible.
Yeah. Anybody, please respond. Whether I have to discuss one by one or.
One major question I had is that we have definitely discussed dynamic dispatching and all of that. Right? And week 4 doesn't make any extra material about dispatching and all that, right? It is only talking about hierarchy, derivation, and dependency or hierarchical structure, right? It doesn't change anything.
Actually, now whenever you're learning the hierarchy, you should understand the method dispatcher. Otherwise, like the actual reason to create the hierarchy will go off.
Yeah, I understand, but I'm saying week 4 there is no extra information about method dispatching.
I think so. Yeah.
Since the method dispatch is clear, the interface, both interface and abstract, these are very necessary implementation in the programming, because without that we cannot do many of the functionality that we typically would want.
Yes.
Is that a reasonable assessment of the need?
Yeah, definitely.
For
interface or abstract class show your capabilities, right? And it is implemented whenever we implement it or extend it in a concrete class, right? That is what I told. The reference type, which could be an interface type or an abstract type, which will show your capability of the object. But the implementation comes from the concrete class where you implement the interface or extend your abstract class, right? So the same concept goes over here.
Okay, fine, sir. And then when I read interfaces, I did have a question. When I was watching the video, I was having a question that if multiple interfaces are allowed and all that, overriding is possible, why can't we have multiple hierarchy? But the professor himself asked the question and answered that they have not implemented it yet. Right? You could have conflicting interfaces, but you can't have conflicting classes. So that is still.
Yeah. Anand sir, you want to add something? regarding this?
No, sir. Hello. Am I audible, sir?
Yeah, yeah.
Yes, sir.
Okay. So shall I discuss one by one, or any
I
particular?
Yes, sir.
think
Here
So
is
you can
this is a-
discuss one by one.
yeah, this
One
is a
by
quite important thing. Yeah.
Yeah. Okay. See here. Okay. First, practice programming assignment. So see here, implement the code as instructed in the comments such that it satisfies the given test cases. Okay. So see here in this program. Okay. So first, what it given? So one interface searchable. Okay, is given. So what is the method here? Here search is the method. Okay, it takes two parameters. First one is starting index, and second one is key. Okay, which is of type object. Okay, so now whatever the class implements this searchable interface, okay, that should override this search method. Am I correct?
Yes, sir.
Yes.
Yes. Okay, otherwise your class will become what? Abstract. So here there is no keyword mentioned abstract before sorry, in this method signature. Is it mandatory or optional?
No, there is here for interface, we don't need it because by default it is abstract method anyway.
Yeah. So if you forget to give abstract before, okay, so automatically it will add public and abstract both. No, already we discussed in previous session, right? Okay. Now here one class is defined. Okay, class name is what? Char. Char is a class and it has only one instance variable, that is char. Okay. So now, so this is initialized by the constructor. Okay, like this. Okay. Yeah. Now here we are asking to implement equals method for char. Okay. Here implement equals method. Okay, same like in previous okay, practice programming assignment. Okay, so here you should, okay, override. Okay, already the template code is given. You should implement the code, required code, in this equals method. Okay, next here, see, so class char array implements searchable. Okay, now, okay, this char array class should implement the search method. Okay, see here, public int search. Okay, int starting index and object key. Here what you need to do here? Okay, so search the key in the array. Okay, CARR from the index, starting index. Okay, you should start from this index. Actually here inputs are given, like one string is given as input and we should find the key. Okay, key is a character. We should find. Okay, see here in test cases. Okay, yeah. So
In
here,
in the description, it is not clear whether the key is a character or a substring.
here key is a character only. Okay, key is a character only. Okay, so here a string is given as a input and key is a character type here. Okay, you should find, okay, this key is present in the, okay, given string or not. Okay, so if it is found, it should return the, okay, position, okay, where it is found. See here, I can write a Java program. Okay, see here where it is found. So in this position. Okay, so 4 is the position. Okay, so next you should learn Java. So here I want to find this key. X is a key I want to find. So here there is no key presented in the given string. So it will return 0 like that. Okay, and we have one private test case also. Okay, so like this. Yeah. Now see here. Yeah, in search method. Okay, what you need to do? Okay, so here the instructions are given as a comment. Okay, so here actually you need to start from the given starting index. Okay, so you need to traverse through the what given array. So here CRR is there, no? So this is input array. So you need to traverse through this, okay, array one by one character, and you need to apply the, okay, what search method.
Yeah, that's
Okay.
first. Before that, we have to check whether the key is actually of type char.
Yeah, that should be written in the, okay,
First, right? If it
equals
is not
method,
an
no?
instance of char, we should return some error.
Yeah. So yeah, we'll come to that. Okay. Okay. So if key is found, okay, it should return the index of the first occurrence of the key. Otherwise, it should return the -1. Okay. So this is the code you need to you should write in the search method. Okay. Yeah. Next. So in frequency counter, see here, public static int. So this is of type static, no? So you can call this get frequency method directly by using, okay, class reference, sorry, class name. So frequency counter dot get frequency. So what are the two parameters here required here? So first one is the searchable, okay. Second one is the key, okay, key. So here some template code is given here, okay. Yeah, what is the template code here? So if OB is instance of, okay, character array, okay, OB is instance of character array, then count, okay, occurrence of the key in the OB using search function. Okay, so this is the code, okay, you need to write here. Okay, so totally see here, okay, here you need to implement the equals method, okay, equals method. Next, here you need to define the search method, okay. Next, here you need to call the, okay, search function here, okay. Yeah, now so come to the solution, I will explain here. Yeah. So see here, so every, okay, so function, sorry, every program execution starts from the main method, right? So here, see, in main method, so there are two local variables, str and c. So str is string type and a character, sorry, c is character type. Okay, now, so here we are going to read the input values. Okay, so first one is what? First one is string, okay, input string, and second one is key, okay, whatever the key you want to search. Okay, so see, so both I'm going to read, okay, by using, okay, scanner class. Okay, so actually there is no method, okay, there is no method to read, okay, to read what character using scanner class. Okay, so that's why here next line is used to read the, okay, string, okay, and next is also used to read the string. Okay, so here what is the difference between next line and next? Okay, so next line will read the string up to whenever it encounter the space, it will stop the reading of the string. For example, here for suppose here I given like AID, sorry, here. Okay. So here next line, what next line will do and what next will do. Okay, see here, for suppose I given like this, IIT Yam, okay, Chennai, like this. Okay, sorry, Chennai, like this. So now if you give like this, okay, next line will, okay, next line will read up to end of the string, but sc dot next will, okay, read the string, input string from starting index to whenever it encounter the space. After encountering space, it won't read, sorry, it won't read after encounter the space. So that is the difference between next line and sorry, next line method and next method. Okay, so next line will read entire line, okay, up to end of the string, but next method, okay, will read the string up to when encounter the space. Okay, so this is the difference. Okay, so here what I'm doing is actually, sorry, Actually, there is no method to return character in scanner class. So that's why I written sc.next dot caret of 0. Means here in test cases we are going to give only one character, okay, for this C. Okay, so that will be treated as a character. Okay, for suppose see here. So here I'm giving Java program, okay, for str for this, and for C what we are giving is for suppose I given A. So by default it is okay. So what type? String type. A is a string. So now what I am doing is caret of 0 means dot char at, okay, char at of 0, okay, caret of not o 0, okay. So it has only one character, okay, it has only one character. That one character is A, no. So now that is going to store in the characters here. Okay, is it clear? First I'm going to read a string, okay, that contains only one character. Now I'm getting that character, I'm going to store in this character C. So there is no predefined method in scanner class to read the character. That's why we written code like this. Is it clear?
Yes, sir. But in command line, when I am giving input, suppose I have written this program and now from command line, I have to give the input to execute the program. So for the first, when I am giving input for str, I will write a paragraph and then press enter, and it will automatically come to the next input,
Yes.
right?
Yes.
But for the next input, I will pass only a single character. So suppose A, and then I press enter.
Yeah, you should press enter, no? Then only remaining code is going to.
But if I do some mistake, instead of single character, I pass A, B, C, then press enter, then also by default it will take A.
Yeah, because here you written what? Caret of 0, no?
0. Achha.
Yeah. Okay. Yeah. Now here I'm going to create an object for character class here. So char key is equal to new char of C. Okay, char key is equal to new char of C. Yeah. Now what happened? Okay, whenever you create an object for char, now you tell me, just object gets created or any something else? Okay, what happened here?
It
Only
will call
objects.
Call its constructor above.
Yeah, super. Okay, now it is going to call the constructor. No, so now it will come to the constructor of the character. No, where it is? Here it is. Now this char is going to initialize. Okay, so this is going to initialize. Okay, so for suppose, okay, here I'm going to take one test case. So here, what is the test case? First one. So I can write Java. I can write Java program is a string and A is the okay. So key I want to search in the given input string. Okay. Now C is initialized by, you tell me. C is initialized by what? Here in character class.
A.
Sorry. 1 second. Yeah, here C is initialized by A, no? Yeah, this is happen. So whenever you create an object for char class, okay? Yeah. Now after that, see here char, okay? So CA. So what is this? What is this?
So variable.
Character
array.
Character array. Okay. So whether it is predefined or user defined?
It's user defined.
Yeah, user defined. Okay, character array object. No, so char of CA, okay, is equal to new char of, okay, str dot length. Okay, actually this is an array, no, so here we should mention the size of an array. Okay, size of an array, so it is, okay, size of given input string. Okay, given input string. Okay, so whatever the size, okay, of the given input string, so it is going to it is going to get by using length method, and it is substituted here. Okay, for suppose here, what is this, I can write, sorry, I can write, okay, Java program. Now you tell me what is the length of this length. See here we have 3 spaces, no, so these are also treated as a character. Okay, no, so here 1 3 4 and 5 9 4 13, here 1 2 3 4 5 6 7 20. So totally how many characters are there here? What is the
20.
length? 23. Okay, 23. No,
24, sir.
see here,
4 spaces.
sorry, here 4 spaces, no, yeah, so 24. What happened? Sorry, my pen is not working. Yeah, so 24. Yeah, now at runtime, okay, not at compile time, so runtime, it is going to replaced with the 24 here. Okay, yeah, see, new char of, okay, 24. Okay, now here character array, okay, is created with the length 24. Okay, now what happened here? See here, int I is equal to 0. Okay, here index is starting from 0 and I is less than str dot length. Now what is the length here? You tell me, what is the length?
24.
24. Okay, 24, and okay, so I is incremented by 1, means here it is starting from 0th index up to its length. Okay, up to its length, it is going to get 1 by 1 character. Okay, 1 by 1 character from the given input string. Okay, I can write, okay, Java program, no, so for first iteration it will get what? I. Okay, I. So now here CA of 0. Okay, CA of 0 means one object is created. What object? Character object is created, is equal to new char of, here str dot caret of I. Now here str dot caret of I means here, okay, so first object is created, okay, with which character? I'm asking for first iteration. Okay, now you tell me. For first iteration, I am asking for first iteration. Okay, so here you are, yeah, you are traversing through the what? Given input string. Yeah. Now here object is gets created for character class. Now here. Yeah, what is the character here? I am asking.
I.
Yeah, I. For second iteration.
Space. Space.
Yeah, super. Okay, like that, how many objects are created?
24.
0 to 23 at 24.
Yeah, totally 24, means CA of 0 to CA of 23.
Yes, sir.
Okay, yeah, totally how many objects are created? 24 objects. CA of 0 to CA of 21, means see here, now here see, so this is CA of 0 and this is CA of 1, this is CA of 2, up to this is CA of 23. No, so here CA of 0 object is associated with the, okay, I. and CA of 1 is associated with the character space. Okay, CA of 2 is associated with the character C. Like that, CA of 23, okay, is an object, character object. This is associated with M. Am I correct?
Yes, sir.
Okay, yeah. So now come to the code. Come to the code again. Yeah. Now, what you are doing here? So character array, okay, C A O B J is equal to new character array of CA. Now you are passing what here? You are passing character array. Okay, is it okay reference variable or object array? I'm asking here. You are passing CA. CA is character array or reference variable?
Reference variable.
See here.
It's a character array, sir.
Yeah, it is what character array you are passing. Okay, so after that, okay, so you are going to call what frequency counter dot get frequency, okay, method caobj dot key. Okay, so whenever you created an object for character array, so automatically what happened? So object is created and it is going to call the constructor. Which constructor? Character array constructor. Where it is? Character array. So this one. Now this CARR, okay, is having 24 24 objects. No, am I correct? Am I correct?
Yes.
Yes.
Yeah. Okay. Yeah. Now frequency counter dot get frequency of COBJ. Okay. Here I'm passing what character array object and key. Okay, here key is the A, no, all of you, key is A. Okay, and CAOBJ means character array OBJ. Now your control is going to get frequency method. Okay, so where is it? Get frequency method. Yeah, so this is get frequency method. Okay, so now this OB, so now this OB contains character array object, is possible because here character array is implemented by searchable interface. See here, character array implement searchable. Okay, so now this reference variable is capable of holding the character array object. Okay, so for suppose searchable is not implemented by character array, will it work?
No.
Will it work?
No,
it is not work. No, so it will give compile time error. Okay, yeah. Now, so whether it is this OB contains whether this OB contains so instance of character array or not. Okay, I'm checking. Okay, so if it is contains so character array object. Okay, now what I'm doing is I'm going to take two local variables. Okay, first one is find index is -1 and int c is equal to -1. Okay, so two local variables I'm going to take here. Okay, so here find index is what? -1 and int c is equal to -1. Okay, yeah. Now what I am doing is, so here do while loop here I am using. So here first statement, yeah, C++. What is C++ here? What happened? This is increment operator, no? Now C will become 0, no? C++ means, yeah. Now find index is equal to so OB dot search of find index plus 1. Find index plus 1. char of key. Okay, char of key. What happened? ob dot search. Now you tell me, ob dot search. Okay, find key. What happened here? Actually, find key is the -1, no? +1 means here what is the starting index? Actually, search contains two parameters. First one is starting index. Okay, now starting index will become 0. Okay, next here you are passing what? Character. Okay, key is a object type. Sorry, here key is a object type. Okay, you are casting it to char. Okay, you are casting it to char. Okay, yeah. Now it is going to call which method? Search method. No, search method. So here what happened? So here key is okay. So key contains, actually here we are not passing. Okay, here we are not passing a, actually just we are passing object. Okay, which object? Character object we are passing here actually as a key. Okay, as we know that character object contains a. Okay, character object contains a, but it is not contains directly. Okay, it contains in the C reference variable of the character. Okay, so please remember this. Okay, so because as a input, okay, we given a. Okay, already we given a. So while creating the object of character, so we passed. Okay, so this character in the constructor. Okay, so in character class, okay, variable C is initialized by a, character a. Okay, now what happened? You tell me. So ob dot search of find index +1 comma character of key. Now what happened here? It is going to call search method from which class?
Searchable class. Oh, sorry, character array.
Yeah, so it is going to call from the character array. Now you tell me. Okay, it is going to come here. Now, so here into starting index. Now what is the starting index here?
0.
Okay, here starting index is the 0. Sorry, actually here my pen is not working good. Okay, 0. And here what is the object key? Object key means here actually character object. Okay, character object. Now see here already. Okay, whenever you create this character array object, here character array object is initialized with 24 okay character objects here. Okay, now in this search method, okay, what you are going to implement? So see here int I is equal to starting index. What is the starting index here? Starting index is 0 and I is less than CARR dot length. What is the length of CARR?
24.
Okay, 24. Okay, means here 0 less than 24. Okay, it is correct. Okay, it is correct. Now CARR of I. Okay, CARR of I means what? I value.
0.
0.
Yeah, super. Okay, so 0 means here you are comparing. Okay, you are comparing first object with the key object here. Did you get my point? You are comparing. Here you created 24 what? 24 character objects. Okay, so now the CARR contains 24 character objects. Now I am comparing first object with the key here. Now you tell me. Now you tell me this CARR contains okay which character? Which character? 0.
I.
Which character?
I.
Yeah, super. Okay, it contains I. What this key contains?
A.
Yeah, super. No? Yeah. So now it is going to compare equals method. Okay, so here it is going to compare with the okay. This first object is going to compare with the required key. Okay, yeah. Now it is going to call the equals method. Okay, now let me go here. Equals method. Yeah. So equals method. Yeah. See here, object to D. Actually, you are passing key, no? Key means of which type? Key means here character type. No. So here I'm going to check whether D is instance of character or not. Okay, whether D is instance of character or not. Okay, so if it is okay, character type. Okay, character type. I'm going to cast it into char type, and I'm going to get the okay corresponding reference variable value C. Now what is the reference variable value here? What is the reference variable value here?
A.
What is the reference variable value here? Yeah, super. A. And what is this dot C?
This is I.
Yeah, it is I. Is both are equal?
No.
Both are equal or not?
No.
No. So what it returns? What it returns? If these two are not equal, if equal, it return true. If these two are not equal, no, for first iteration, what it will return?
False, false.
False it return, no? Yeah. False it return. Okay. Yeah. Next. Okay. So it return what? False. False means it does not return anything. Okay. It return something whenever this become true. Okay. So for first iteration, it is false. No. Yeah. Now. Okay. I is going to incremented by 1. Now what is the I value? What is the I value now?
Become 1.
Okay.
Space. No,
No.
one.
Just I'm asking I value, iteration value. Now what is the I value?
1.
One.
Yeah. Now CARR of 1. Now CARR of 1. Second
Yes.
object is associated with character. Which character?
Space.
Yeah, space, no? Now, okay. It is going to call the equals method again. Okay. Yeah. Now come to equals method again. Okay. Equals method again. Same thing here. Now what this contain? What this contain? Same thing.
Yes, it's A only.
It contains what? Space. Okay. Space is not equal to A. No. What it returns? True or false?
False, false.
False.
Yeah. For second iteration also, it return false. Okay. It return false. Okay. So it does not return anything for second iteration. For third iteration. For third iteration, what is the I value?
C.
What is the I value?
2. 2.
2, no? Yeah. Now CARR. Okay. CARR of 2. Now you tell me. What it contains?
C.
C, no? Yeah. Now C dot, sorry, C, not C. Actually, so CARR of 2. Okay. Dot equals of K. Okay. So now again it come to here. Equals method. Now, at third position. Okay. Sorry, at second position. Okay. So object is associated with which character? C, no? Yeah. C is equal to this dot C. Okay. Now C is equal to A. C is equal to A. Is it true or false?
False.
False.
False, no? So okay, it won't return true. Okay. This time also it will return false. Okay. So again it will come to here only. Now I value is incremented by 1. No, I value is incremented by 1. So what is I value here now? 3. Okay, I value is 3. Now you tell me what happened here. So here CARR of I. Okay, CARR of I and I means here 3 equals of K. Again it is going to call the equals method. Okay, equals method. Okay, same. Now char D dot C is equal to this dot C. Now this okay, fourth object contains the value A. Okay, is equal to A. Is equal to A. Okay, A is equal to A. Now for fourth iteration, you tell me for fourth iteration what happened? What happened? It is true, no? Yeah. Now it returned what? I value. Okay, I value. So once it returns something, okay, what happened? This function execution is finished. Okay, so where this search method is called? Where this search method is called? Here only, no? Here. Hello, are you there?
Yes, sir.
Now what is the find index?
3.
Yeah, find index is 3. No?
3.
Yeah, find index is 3. Now where this get frequency method called? In the main method. No? System.out.println of, okay, frequency counter dot get frequency. Okay, so what it is returning? Okay, where it is? Here it is. It return C value. Okay, so for first iteration, okay, now you tell me for first iteration its value is 1. Okay, C value. For second iteration, okay, 2. For third iteration, 3. For fourth iteration, 4. Okay, for fourth iteration only we are getting the required key. Now what it returns? What is the C value for fourth iteration? What is the C value for fourth iteration? I'm asking. What is that? Yeah, 4, no? So for fourth iteration only you are getting the required key. So what it will return? Hello.
It will return 4.
Yeah, it returned 4. Okay. Is it clear? This one?
Yes, it's clear.
Yeah. So this is okay. So first.
I have a doubt.
Okay. Yeah.
So here, when we are calling the search method, we just increment C only once, and then we go and call the search method, right?
Yeah. See here, actually find index value. Okay. So find index value. This loop is going to. Okay. What happened? This loop is going to. Okay. Executed until. Okay. This is what? Not is equal to -1. No. Right. Here find index value is incremented and the C++ also a value is also gets incremented. Sorry, C value also gets incremented.
She is asking why this C++ is done. I think if you got it in the position 5th, then next time you have to search from the 6th position. No, that's why this increment is done. If you got it on the 5th position, next time you'll search from the 6th position. No, if you again search from the 5th position, you'll again get back the same value 5th, right? So that's why you're incrementing. Like if you next got in 10th position, then again you'll start searching from the 11th position. Is it okay?
Means we want to find the last occurrence of the key.
No. The number of occurrence. No, say you're searching from the 0th position. Suppose you got the first occurrence on the position 5, right? So how
yes.
do you search the next occurrence? Next occurrence you need to search from the 6th position, no?
Yes, sir.
You need to find all the occurrences because you are going to find the frequency, right? So
Yes,
that's why
sir.
this plus is done. And see,
Okay, sir,
intentionally that's taken as a -1, no? This equal to -1 so that this increment gives you a 0. So you starts from 0, go on incrementing. Suppose you get it on the 5th position. Next time the loop will return, loop will start. It'll start from the 7th position, sorry, 6th position. Like that.
No, if I, instead of initialization from -1, if I initialize from 0, and instead of C++, do while loop start with C++, I will write it the after that, then what is the problem?
The problem will be, suppose you got the occurrence on the 5th, right? So the value of C is 5th. Now next time the searching will search from the start from the 5th. So on the 5th position, you are already having that value, right? So it go on making 5th, like it will become an infinite loop kind of thing, you know?
Okay. Acha. Okay.
Yeah. But you can give it after this thing, like find index. After that, you can put the C++ if you are making this equal to 0. That's okay. After this find this search statement, you can give the C++. That's fine.
And where we are incrementing this for frequency value for means that part means when it is written find the match, I should increment my count. Now where it is that part.
I'm sorry. This C++ actually basically keeping the frequency. This index find index one is the this thing. Sorry, this find index one is the position, right? Yeah.
Yes, sir. Yes, sir. Sorry.
This
Here,
find
yeah.
index plus 1. This is where I'm incrementing.
And then C++ I am placing anywhere, and I can start with 0.
C++ is actually maintaining the counter, right? How many times have we encountered the key?
Yeah. You're correct. You're correct. I got it. What you're telling.
No, is it necessary that if the frequency, no, if I don't find anything, then I should return?
See, if you are writing a do
0.
while, you should start from a -1. If you write a while, you should start from a 0. That's all.
Okay.
Because this extra plus plus, it will be always done whenever you are on a do while loop, right? This extra C++, this will always execute whenever you are on a do while. But if you have a while loop only, the condition will be checked before it goes into the loop, right? So then in that case, you can make it as a 0. Yeah.
And one more small part, I get confused. Sir, can you just go up? Yeah.
Shall I rub this?
Sir, this part, this.
Shall I rub this?
No, let it be, no issue.
Okay.
Yeah. So can you please explain one more this if statement care of d of dot c?
This one.
Second.
Okay. Yeah.
This part I have one confusion, and second is in this public int search int start index comma object of key. Why I need to pass it object of key when I know the key is the character type?
Yeah. So actually, equals method character is of type primitive, no? So you cannot compare primitive types. So that's why here we are passing object.
Okay.
Is it clear? Yeah.
Okay.
Here this part. Shall I explain this part?
Yeah. Once more. Sir.
Yeah. Actually, here you are passing key, no? Key means here character type actually. Okay, character type. So here object, this D contains, okay, which object? Character object. Okay, so actually here in equals method you are passing key. Okay, key means of type what? Character type. Okay, now this, okay, equals method, okay, object object D. Okay, this contains what? Character object. Now I'm checking. Okay, D is instance of char. Okay, actually here we are not comparing in this method. Sorry, in this method we are not comparing the objects directly. We are comparing the instance variables. Okay, instance variables. Okay, what are the instance variables? Actually, this char of D dot C is equal to this dot C. Okay, are you getting my point? This here actually we are not comparing references. We are comparing the character associated with that object. So that's why here I'm using dot C here. Is it clear?
This is clear, sir. If you don't put dot C, if you just say D equal to C, it will always be false. because they'll
Yeah,
be
yeah.
different objects.
Yes, yes.
Okay.
So shall I move to next question?
Yeah.
Arup sir, do you want to explain this or shall I explain?
You can explain.
This EVM one.
Yeah, please explain.
Okay. Okay, see here. Okay, here, please follow the comments and given code segments to complete the program in according with the sample outputs. Okay, yeah. See here, in this program, okay, so we given like one features, what we call singleton design pattern. Here we implemented in this program. Okay, so actually this is very good concept. Okay, so that's why we given it as a practice programming assignment. We not given it is a graded assignment. Okay, so here we have two objects. Okay, first one is the voter and EVM. So in real time also, okay, so one voter can, okay, one voter can, okay, vote only one time. Okay, not more than one time. So here, vote, if you consider voter is an object and EVM is an object. So one voter, okay, is should, okay, associated with the one EVM object only. For suppose voter one, okay, voter one, okay, should associate with the one EVM one object only, and voter 2 should associate with the, okay, EVM 2 only. Okay, so here one voter should, okay, vote only one time only. Okay, one voter should only, sorry, should vote only one time. Okay, so here every voter object, okay, should, okay, associate with the only one EVM object. So that is the concept here. Okay, so here both the voter and the EVM classes must be created in such a way that they enforce exist only a single instance at a time. Okay, so here voter class and EVM class, these two are the singleton classes. Okay, singleton classes. What is singleton class means? For these classes, okay, for singleton classes, we are able to create at most one object at a time. Okay, you are not able to create, okay, more than one instance at a time for the singleton classes. So that is the idea here. Okay, now here voter and EVM. Okay, if you create one voter object, okay, if you try to create one more voter object, okay, then, okay, so it won't allow because this is singleton class. Okay, so how to implement singleton class, I will show you in the code. Okay, so as of now, what is singleton class? So singleton class means, okay, you are able to create at most one object for that class. Okay, if you try to create more than one object, then it will, okay, it won't allow you to create more than one object. Okay, so that is the singleton class. Okay, here already I said no, each, okay, voter object must be mapped with the unique EVM object and vice versa. Already I told no. Okay, so one voter object must be mapped with, okay, unique EVM object. Okay, yeah, now see here, a voter must be allocated to an EVM and then voting process should be started. Okay, so here whenever, okay, a voter, okay, must be allocated an EVM and then voting process is going to start. Okay, now once voting is completed, okay, once voting is completed, particular EVM should be freed and next voter should be called. Again, new EVM must be allocated to the next voter like previously, and the process continues till voters cast their, okay, like this. Means for first vote, okay, for first vote, both the objects gets created. Means voter one and EVM one here. two objects, voter one object and EVM one object for first voter. So once voting is completed, these two objects are going to null. Okay, these two objects are going to null. Now we are going to create one more object whenever these two become null. Okay, if these two are not null, what happened? If you try to create one more object, what happened? What happened? Voter and EVM. Okay, these two, okay, are the singleton classes. Okay, if you try to create one more object, okay, so without, okay, making these two as null, okay, so these two classes won't allow to create more than one object. So after making these two as null, I'm going to create a second object, 2, 2. Okay, so now start the voting process like this. Okay, and if you want to, okay, if you want to allocate EVM to one more voter, okay, then you should make null these two as null. Then only you should create fresh object, voter 3 and EVM 3, and allocate this EVM object to the voter, then start the voting process like that. Is it clear?
That means it is both way 1:1 map. Means if at a single time in a EVM machine, two voter cannot vote.
Yes, yes.
And one voter at a single time cannot vote two EVM machine.
Yes, yes.
Okay.
Okay. Shall I rub this?
So how do you set it to null?
Hello, somebody is speaking, but I'm not able to listen properly. Can you repeat once?
So how do you set it to null?
Yeah, we'll see. Just we can. Okay, so reference variable is there, no? So reference variable is equal to null. That's it. Automatically, it will become null, no? Okay, for suppose, see here. So voter, okay, voter is equal to new voter of. So you created instance. So after that, you are going to make it as null once voting process is finished. After then only, okay, create the object. Actually, this is not correct way to create an object for a singleton class. Just for your, okay, doubt clarification, I am telling like this. Okay, so first I'm going to create an object for voter. Okay, so voting process has been started. Okay, so once voting is finished, then I'm going to make it as null. Then only, okay, I'm able to create another object like this. Is it clear?
So, yes, sir.
Yeah. Okay, see here. Here, voter class is given. Okay, so define appropriate variables for implementing singleton behavior. Okay, so we'll see what are the appropriate variables here. Okay, in accordance with a given coded part and sample output. Okay, see here. Okay, so in order to, okay, so make a single class, sorry, your class as, okay, singleton, you should declare your voter class as, okay, sorry, your singleton class should have private constructor like this. Okay, so it is mandatory because we should not allow, okay, we should not allow, okay, other classes to create an instance of singleton class directly. Okay, so by using this get voter class, okay, so we can give a chance them to create an object for voter class. Okay, so we should here voter class does not allow, okay, outer classes to create voter class object directly. Okay, so you should call this get voter method in order to get the object of voter class. Okay, so like this. Yeah, now I'm going to explain clearly. See here. So both should be implement the singleton behavior. Okay, yeah. Now see here. Here class order. Okay, so here this required three instance variables like this. Okay, so actually this is a reference variable and these two are the instance variables. Okay, so public static int total number of voters. Okay, so total number of voters as of now it is 0. Okay, as of now it is 0 default value. Yeah, as of now it is null, so it is a reference variable now, so it is null. Okay, and initial value of this current voter count is 0. Okay, and here, yeah, see here, this is private constructor. So as it is private, you are not able to create an object for voter outside of the class. Okay, yeah. Now here whenever you create an object for voter class, okay, so here current voter count is going to incremented by 1. Okay, yeah. Now here public static voter get voter. Okay, so here get voter. Okay, already I said, so this voter class is what? Singleton class. Okay, it won't allow, okay, to create more than one instance. Sorry. Okay, more than one instance. So first it is going to check whether it is null or not. Okay, new voter is equal to null means, okay, so there is no object before. Okay, then only it will create, okay, object like this. Okay, new voter is equal to, okay, sorry, new voter is equal to new voter of like this and return it. Okay, for suppose already it is instantiated. Okay, it is already instantiated, then it return null. Okay, then it return null. Okay, so here get voter method, okay, return what? Object of voter class. Okay, object of voter class if and only if, okay, this new voter is null. Okay, means there is no object before, then only it will create and return it. If already this new voter is there, then it will return null. Okay, it won't allow another object to create. Okay, is it clear? Singleton design pattern, actually it is called as a design pattern, so that is a different concept. Yeah, is it clear? Singleton class.
Yes, yes.
Yeah, okay. Next, we'll come to this code later. Okay, yeah. Next, EVM. So both should be singleton behavior, no? Yeah. Now here, what are the required reference variables here? Sorry, required instance variables. So here, this is reference variable. By default, it is null. Okay, yeah. Next, its count is 0 by default, and the private static EVM. This is also reference variable, no? So this is by default null. Okay, yeah. Now this is private constructor of the EVM. So for EVM class also, you are not able to create an object outside. Okay, so in order to get a instance of the EVM machine, you should call this get EVM method. Okay, so whenever you call this get EVM method, okay, it is going to check is there any other object, okay, before, okay, calling this method. Okay, if, okay, any other object is present in the class, okay, then it will return null. Okay, otherwise it will create an object and it return it. Okay, if there is no object is created in the in this class, then it is going to, okay, null. Otherwise, okay, so if it is there is no object before, then, okay, so it is null, no? So null is equal to null, then it will create. For suppose already object is there, okay, already object is there, then it is not is equal to null, then it will return null. Okay, yeah. I hope this singleton okay concept is clear, right? Is it clear? Singleton concept.
Yes, sir.
Yeah. Now already I said no. So our execution starts from main method. In main method, yeah, scanner s is equal to new scanner of system.in. We created an object for scanner class here. Yeah. Now voter dot total number of voters. So as it is defined as static property, we should call it by using the class directly like this. Yeah, voter dot total number of voters is equal to s dot next int of. For suppose here I given 2. Now total number of voters is initialized by 2 here. So now it is initialized by 2. As of now, just as of now. As of now. Yeah. Next, what you are doing here? You are asking, voter v is equal to voter dot get voter. Get voter. So what happened here? Voter dot get voter. So actually here get voter is a static method. You can call it directly by using class name. So voter dot get voter. So now is it written voter object or it written null? I'm asking whether it written voter object or whether it is written null. You tell me. Null or voter object? Please tell me. See here.
Voter object, right?
Yeah, voter object. Why? Because so by default, sorry. So till now you not created any voter objects here, no?
Yes.
So whenever you call get voter, so now control will come to here. It is going to check. So this new voter object is null or not? Is it null or not?
Null.
Null. No. So now what happened? So it is going to execute these statements. Now what happened? New voter is equal to new voter of. What happened? Now object gets created for voter class and return it. So next control come from here to here. No. So whenever you create object, automatically constructor is called. Now what happened? Current voter count is incremented by 1. What is the initial current voter count here?
0.
Initially 0. Now so whenever you create an object, automatically constructor is called. In constructor, you are incrementing the voter count. Now what is the voter count? Current voter count I am asking is the 1. Now first voter come to vote. Now it is returning new voter. So now your control is going to come to the main method. Now this voter object v is going to initialize, right? Yeah. Now if you are trying to create one more object for voter, now see what happened. So this is a different concept. So as of now, please leave about this try and catch. Yeah. So here voter x is equal to voter dot get voter. Now what happened? Is it null? Voter object. Again it will come to again it will come to where? This get voter method only. Now you tell me, please. Yeah. Is it null? New voter?
No.
No, not null. No. What it will return?
Null.
No.
Null it will return. No. Yeah. Null it will return. Null it will return. Now this x is initialized with null. X is initialized with null. So here null dot call new voter. Actually it is not possible. We should not call any method using null reference. Then null pointer exception is raised. So automatically your control will come to corresponding catch block and it is going to execute whatever the code in the catch block. So voter is singleton is going to display. If you know this try about exception handling before, you can easily understand. But as of now, already I told you, no. So here, if you try to create one more object, what happened? It return null. So if you try to call a method with the null reference, okay, null reference, it won't accept. So okay, null pointer exception is raised. Okay, so I'm handling this null pointer exception, okay, by using try catch. So immediately your control will come out from the try block, okay, and it is going to execute whatever, okay, the statements in the catch block like this. Okay, so it is going to display order is singleton like this. Is it clear?
Yes, up to this clear.
Yeah. Now, okay. So now our program is started. Okay. Yeah. Now you tell me v dot first order. This method is going to call from which class? Order class or EVM class? Order class or EVM class?
EVM.
EVM
EV.
class. First
See.
over where it is.
See here, v is reference of which class?
Oh, voter class.
Yeah, voter class, no? Yeah. So here v dot first over means it is going to call this first order method from voter class. Okay, now we should go, okay, to voter class. Where it is? Here it is. Okay, yeah, first order. Yeah, now first order. Okay, it is going to check. Okay, so new voter, okay, not is equal to null means here voter is ready. Okay, voter object is ready. Okay, voter object is 1. Okay, now current voter count is 1. Okay, new voter not is equal to none means here voter object is created. Now voter is ready. Then only we should, okay, create an object for, okay, what? EVM. Okay, so now EVM new mission is equal to EVM dot get EVM. So here, so we cannot create object of EVM outside, no? Okay, so we are going to ask, okay, we are going to ask EVM class to, okay, I want EVM, okay, object, please get it. Okay, get EVM. Okay, so here I'm asking by using its class. Okay, so it is static, okay, sorry, static method, no? So directly we can call it by using class. So EVM dot get EVM of by passing what? New voter object as parameter. Okay, now what happened? So EVM dot get EVM. So it is going to refer which class? EVM class. Where it is? Yeah. Sorry. Get EVM. Yeah. Here is no. Now current EVM. Okay. Is equal to null or not? Current EVM. Is there any object before?
No.
No. So it is going to create what? Current one object. Okay. Object by passing voter object as parameter. Okay, now what happened? Okay, your control will comes to here and here. Okay, now your reference variable current voter is initialized with the voter object and your EVM count is going to incremented by 1. Okay, now what is the EVM count? What is the EVM count? Now
0.
Now,
1.
after creation of object 1. Okay. Now voter 1 and EVM 1, right? Okay. Voter 1 and EVM 1. Okay. So what it return? It return the EVM object. Okay. Now go to the, okay, first voter method. Okay. First voter method. Okay. So it return what? Okay, EVM object. Okay, now new mission dot start voting means here start voting method. Now both the instances are ready. Here voter instance is ready and the EVM instance is ready. Okay, now new mission dot start voting means now starting voting process should be start. Both the object is ready. Both the objects is ready. Okay, yeah. Now go to start voting. Where it is? Yeah, start voting. Yeah, what it is going to print? So voting under process on EVM number. What is the EVM count here?
1.
Yeah, Okay, so voting under process on EVM number 1. Okay, EVM number 1. After that, okay, after that we are going to make, okay, we are going to make what? Current EVM as null. Okay, current EVM as null means voting process is completed. So after that, what I'm doing is I'm making this current EVM object as null. Okay, after that, what I'm doing, current voter dot call new voter. Okay, see here, here EVM is null. Okay, as of now, okay, I made EVM object as null. Still current voter object is not null. Okay, not null. Okay, so here what I, here voting under process EVM number 1, so it is going to print. After that, what I'm doing is here I'm making current EVM object as null. After that, I'm calling new voter. Okay, I'm calling what? New voter. Yeah, so it is going to call new voter. Yeah, here it is. Yeah, now here I'm making new voter as null. Okay, I'm making new voter as null. Okay, yeah, now voting, okay, completed for voter. Voter, what is the current voter count?
1.
Okay, so both the, okay, statements gets printed. Okay, what are the statements? Here voting under process on EVM number 1. After that, I'm making EVM object as null, and I'm going to call the new voter. In new voter, what I'm doing is, okay, what I'm doing is I'm making this new voter object as null. Okay, so both the objects, okay, what I have done is I made both the objects as null. After that, okay, I'm printing the message voting, okay, completed for voter 1. I'm printing. Okay, so actually how many number of, okay, voters are there? How many number of voters are there?
2.
2 voters. Okay, so now we should check. Okay, we should check. Okay, yeah, here I'm going to check current voter count. What is the current voter count? Current
1.
voter count 1. Okay, is less than total number of voters. What are the total number of voters? 2. 2, no? Then we are going to create one more what? One more EVM object. Okay, for suppose total number of voters also 1, what happened?
It will go out.
Okay, so program is also, okay, execution also completed, because see here, if and only if, okay, so current voter count is less than total number of voters, then only we should go for, okay, what? Start voting again. Otherwise we don't go for start voting again. Okay, so as of now, what is the current voter count here? 1. Okay, now what is the total number of voters? 2. Okay, so 1 less than 2. Okay, now what I am doing here, I'm going to create one more what? EVM instance. Okay, so here EVM dot get EVM. Okay, so first it is going to, okay, EVM class. Okay, where it is? Here. Okay, again it is come to here, get EVM. Okay, yeah, it is going to check current EVM is null or not. Already we made it as null, no? Okay, current EVM is null. Null is equal to null. Now current EVM is equal to, okay, new EVM of V. Okay, and return it. Okay,
No, sir. Before that, it will go
yeah,
to the
yeah,
get
yeah,
voter,
yeah,
no?
I will come to that point. I will come to that point. Okay, so this should be happen. Okay, so before that, yeah, before that, in call new voter, no? So before that, before calling this method, okay, so what is there here? Get voter, no? Get voter, no? So before calling this method, it is depending on the what method? Get voter method. Okay, so which method is executed first? First, it execute the get voter method because its return type is required to call the get EVM method, right? Am I correct?
Yes.
So in order to call this get EVM method, okay, so this return type is required here. Okay, so first it will go to the get voter method. Okay, yeah, so it is going to check whether this voter object is null or not. Already we made it as null, so obviously it will return, okay, the object of the new voter. Before that, see here, whenever you create an object for, okay, so here get voter is going to create an object for new voter. No, now current voter count is going to increment by 1. What is the previous current voter count?
1.
Now it is incremented by 1. Now what is the updated current voter count?
2.
2. Okay, yeah, now object is returned. Okay, object is returned. Okay, yeah, now here it has the voter object here. Okay, now you are going to, now this get EVM method is going to call. Okay, where it is? Here it is. Okay, so here also it is going to check whether current EVM is null or not. Okay, it is null, so it is going to create an object for what? EVM, and it will return it. Okay, so now it is going to come here. Okay, come here. Now here I am going to try, okay, one more object. I want to create one more object for EVM mission. Now what happened? You tell me. You are trying to create one more object for EVM. What happened this time? What it will return? Null or what it will return? You are trying to create one more object for EVM. What happened? Already object is there, no? We created. So here you are trying to create one more object. So obviously it will return null. Okay. And so whenever you want to call, okay, method by using null reference, automatically null pointer exception is raised. So your control will come out from the try block immediately, and it is going to execute, okay, whatever the statements in the catch block. So EVM is singleton. It is going to display EVM is singleton. Okay, after that, okay, so new mission dot start voting. Okay, yeah, now it is come to start voting again. Where it is? Start voting, sorry, start voting. Yeah, here only, no? Yeah, now voting under process on EVM number. Now you tell me what is the EVM number now?
2.
2. Okay, so why? Because whenever you create an object for EVM, automatically EVM count is going to increment, and no, so previously EVM count is 1, now it is 2. Okay, voting under process on EVM number 2. Okay, after that I'm going to make EVM, okay, object as null, and I'm going to call new voter. Okay, now here call new voter. Here I'm making, okay, voter object also as null, and voting completed for voter 2. Okay, voter 2. Okay, now you tell me, actually how many number of voters are there? How many number of voters are there?
2.
2, no? So we are, okay, we have, okay, conducted voting for first ATM object with, sorry, first EVM object with first voter, and second, okay, voter object with second EVM object. So both are completed. Okay, so now here I'm going to check. So what is the current voter count?
2.
What is the current voter count? 2.
2.
What is the total number of voters count?
2.
Okay, both are equal. So actually voting is completed. No, voting is completed. Here I'm checking whenever, okay, current voter count is less than total number of voters count, then only we should create one more object for EVM class and voter class. Then only we should start voting again. Otherwise, we won't do. We won't call start voting process again. Okay, based on this condition only. Okay, we are going to call the start voting method again based on this condition. It is very important condition. Is it clear?
Yes, sir. So one thing I want to ask, we have separate class for EVM and separate class for the voters, right?
Yes, yes.
And those are private classes.
No, those are not private classes. Just they have what private constructor. That's it. These two are not private classes.
Okay, sir.
Yeah.
So when
Why I'm making this constructor as private means I don't allow other classes to create object for my voter class outside. That's why I'm creating this constructor as private. I don't want to create this voter object outside of this class. Yeah. You can ask them. Hello.
Yes, sir, got it.
Okay. If anybody have doubts, you can ask.
So will this document be shared to us today?
Okay, I will ask the sir and I will let you know. Okay. We'll share. Okay. So before that, I need to ask the sir and I will.
So because in the supplementary contents tab, the previous practice assignment solutions are also not there uploaded.
Okay. Okay. I will ask and
no, actually we don't give it. We expect you will solve it yourself.
Okay.
Yeah. So that's the idea is. So if you look at this program, this is typically the example of callback. If you read the callback, that particular chapter, that week 4 callback concept, it's basically the same thing over here. So there are two objects, voter and EVM. The voter is calling the EVM and passing its own object. So whenever the voting is done, EVM again calling who is the next voter. If you look at, that is the only concept which is captured over here. So please try to do it yourself. And if you are not able to do, you are having an error, so we'll help you to solve it. But I think it is better to do your own. But if you have a problem with an error or something, we'll solve that. Okay. So Anand sir, do we have anything else?
No, sir. If anybody have this, you can ask. Otherwise, we'll close the
So I
session.
have a doubt, not in the practice assignment, but a conceptual doubt.
Yeah, please go on.
Sir, in the multiple inheritance concept, we say that we will implement the interfaces because we don't want the contradictory definitions of the functions to clash. Right, sir?
Yeah, we do multiple inheritance for the interfaces, but
Yes.
we do not do it for the classes. Yeah.
Yes, sir. So, so in the interfaces, what we describe, we should not give definition for any functions, right? We should not implement
We don't
any
give, no, in the interface, we don't give the definition, right? Some functions are abstract, right?
Yes, sir. So that's what my point is. The abstract classes should not have the definitions for functions. So please, will you open week 4, activity 4.1, question number 4.
Activity
4.1.
Sorry, sir.
Fourth question.
Okay.
Yes, sir. Yeah. So here the maths class is abstract, and there is a method find factorial in it, but it is having its implementation.
No, interface will have all the methods as an abstract, no? But abstract class and abstract method also, concrete method also. Right? Interface, if you are having an interface, all the methods are abstract, right? You won't have the definition, but abstract class and can have normal methods also, abstract method also, right? You can consider three kinds of things. Normal classes, which will have all the implementation for the functions. Then abstract classes, you can have the functions with implementation, without implementation, means the abstract method. And if you go for the interface, there is no implementation, all the methods are abstract. See, the abstract class and abstract methods are different thing. Abstract method means the method do not have a implementation. Abstract class means the class can have a abstract method, but it is not mandatory all the methods have to be abstract. For interface, it is mandatory all the methods have to be abstract.
Okay, sir, got it. But sir, one more thing. What is the point saying the class to be abstract when there is no abstract method in it?
That's basically we give it as a capability that it can have in future a abstract method. Yeah, definitely abstract method makes sense whenever we'll have at least one abstract method, but syntactically it is fine. We can say it is expected to have at least one abstract method.
Yes, sir.
But what you are telling, that point is absolutely correct, that if you're not going to put an abstract method, there is no point to give an abstract class. That's correct, but syntactically it's okay.
So, but in such questions, the question which is in front of us right now, in such questions, like we do not have the future perspective that in future we'll provide it with some abstract method.
No, I'm telling, if you have an abstract class without abstract method, syntactically it is okay. There is no error, right?
Okay, sir. So it's
That is what
as good as the class.
Yeah, it's like it's okay, like abstract. No, it will be treated as an abstract class only. If you mark it as an abstract, means you cannot have an object of it.
Okay, sir.
It will be treated as an abstract class only, but it doesn't raise an error because you don't have abstract. That is what I'm saying.
Okay, so got it. So means abstract classes can have abstract methods or they cannot have, but
Yeah.
interfaces should always have abstract methods.
Yeah, that is what I'm saying. If you have a concrete class, all the methods needs the implementation. In abstract class, you can have abstract method. In interface, all the method have to be abstract. That is what I'm saying.
Okay, so got it. Thank you.
So when we are defining this abstract class, we cannot create an object on math, right?
Direct object we cannot have, but we can realize it to the child class object.
Yeah, right. That is okay. Okay.
So anything else?
I had a couple of questions. Srinivasan.
Yeah, please. Srinivasan, please.
Yeah. So on the previous question about sharing the code, did I understand that you plan not to share the code? You would expect people to be able to write the code from scratch, right? That is the.
Yeah, we expect it, and we want, if somebody is not getting, let him discuss in the forum, or in the live session or in the forum. And one more thing, like what I say, like we normally again reopen this practice assignment so that you can practice once again.
I understand. And there are other courses also in the program which take that similar approach, right? Like MLT and all. They discuss code quite a bit, but they never share the code. I understand. So that's what I'll just share. What I find it useful is to take the video, look at that.
Yeah, you can do that, but
then pass it and write the code.
Prefer it, we write your own.
Yeah. Yes, sir. And another question, I would look at the previous Java questions, but after seeing the graded assignment question, I have one issue about the length of each question. So even if you say even this question, right? A question like this doesn't fit well in the online test. The platform that we have, the screen is so small. Would we have such questions with a lot of programming and you have to go back and look at the code again and again?
See, we try to fit the code within a A4 sheet. That's our idea. It's not more than one page.
Yeah, so but
Normally.
okay, my feedback, I look at it. The problem is in the online when we have where we write the
Yeah,
test.
I do understand that, like rather we do understand it, but there is no way to testing it other than that, right? Java, like there is lot of syntax. So if we do not keep some amount of code, we cannot actually test your the capability to write the code or understand the code. That's the problem. So for that, what we consider, we do not make it more than one page count.
So even one page in the test would mean 2-3 scrolls, right, back and forth.
A little bit scrolling you have to do,
Yeah.
but we
And
cannot
I
avoid
hope
that.
even the number of questions is set with this in mind, right? So hopefully we'll be able to do it.
Yeah, we will do.
Thank you.
Okay. Okay, shall we close? Because
Sir,
already yeah.
Sir,
Please.
one last doubt.
Yeah, please.
So this is in respect to the concept that you explained today in the beginning.
Yeah.
So will you please open activity 3.6 question number 2?
Yeah, Anand sir.
So 3.6, activity 3.6 question 2.
3.6.
Yes, sir, this question. Sir, in the last second line, we can see that an object of type B is being created, and then it's calling the show method for it.
Yeah.
So here I am confused actually. Since B type object is being created, we'll call the show method for B, right?
Yeah.
So it should print out B show. B show is being called.
Let me check out. Is there anything? No. Because this is having a overriding problem, I feel.
Yes, sir. Actually, here access specifier is public, and here we not mentioned anything. No, so it become default. So we should not decrease the visibility. So that's why
This
it will
gives
throw.
an error because the signature is not seen in the overriding. Because if you don't write it public in the child class, so the signature gets changed for the overriding, right? So that's give you a problem, error. Getting my point?
The default, right?
It becomes a default. So signature becomes different in the overriding, no, which is not allowed basically. Actually, what is not allowed, whenever you are overriding, you can expand your scope, but you cannot shrink your code scope. Means if you have a default, you can make it public, but public cannot become a default.
Okay.
Okay. So what sir is saying, like, so for suppose here just void show is there, and if you write public void show here, it is valid. Am I right, sir?
Yeah.
You can increase the scope, but it should not decrease.
Means if you look at the scope, means to say private means within the class, right? Then you are having default. Default means within the package. Those are not done actually. Then we are having protected, which is having higher scope. Public means it is accessible anywhere, that highest level of scope.
Okay, so means
You
in
cannot
class A,
reduce the scope. Yeah.
sir, in class A, if I do not put public,
Yeah.
then also it will be okay, right?
In the class A, if you do not give public, then also it will be okay. Yeah, it will be okay.
Yeah. Okay.
You'll get the what you're telling. Like
The only thing is both the signatures should match.
Yeah. That's
Okay, so got it. And sir, if I match the signatures, the output will be B show called,
yeah,
right?
be sure. Yeah. It should
Okay,
be.
sir.
But
Okay, sir. Thank you.
Arup sir, in signature, we are considering this accessor. We are only should see the function and whatever number of parameters.
Actually, it's not part of the signature, but what will happen? The rule says for overriding, the accessor should be expanding, not be shrinking. Means on the top, if you are having a default or protected, you can make it public during overriding.
Oh, okay.
But it is public, you cannot make it protected or like which is having the limited scope, right? That's the idea.
Okay, thank you. Got it.
Okay. So shall we close? We're having again a session. Yeah. Anything else?
No, sir.
Okay, so we are done, right? Thank you. Thank you all.
Thank you.
One last doubt, if you can.
Okay, okay, please go on. Yeah.
Sir, I am actually not getting what is the importance of this word keyword static when we use it in code.
Shall we take it in the next class?
Okay, sir, fine, no problem.
Okay, okay.
Okay.
I think because it will take time. Static is a big thing, and we haven't covered that much in the lectures.
Okay, sir. So for now, if I use static or if I do not use, that will
For
not
the
matter.
time being, you remember if you have a static method, you don't have to call using an object
I don't have to call.
to an object. You don't need a object for calling a static method.
Okay,
If you have a normal method like a show over here, you have to call like object.show, right?
yes, sir.
But for a static method, you don't have to call using the object. We'll do it next class. Further.
The static have a single copy in the memory. It will not have multiple.
No,
copies.
those are many things we need to discuss in details. In so time, it needs some time. But for the time being, what I'm telling, if you have a static method that do not require the object to be invoked.
Okay,
See,
sir.
if I want to call the show, I have to create an object of B, right?
Yes, sir.
Then only I can call. But if it is a static, I don't have to create an object.
So how do you call it then?
If it is on the same class, then we can directly call it. Like if the show is belongs to the example class, I can just call it as a show. But if the show is belongs to the B class, then I'll say B
Dot show.
no, yeah, B dot show.
Mhm. Okay, sir.
Okay.
So if I've created it as static in class B, then I'll not have to create an object in class example. Is it?
If you call it in the object B, class B.
If I have created it as static, void static show.
Yeah,
then
void
I'll not
static
have
show,
to-
then you have to call B dot, not a object dot, it's a class name dot show.
Okay, sir. Got it. Got it. Thank
But
you, sir.
there are more things about it. We'll
Yes, sir. Yes, sir. But for the time being, I can this can satisfy me.
Yeah. Okay.
Okay. Thank you, sir.
Thank you. Okay, anything more? Okay. Anand sir, shall we close?
Yes, sir.
Okay, thank you all.
Thank you, sir.
Thank you, everyone.